They kept going. And in fact, what I don't show you here is it turned out that there were more earlier career, younger investigators part of the T-Turks than as PIs on the R01s. And those people were having the opportunity to publish more papers earlier on in their career. And that's very important. But even if we look past volume of any year, but we look at cumulative publications, we see the same trend. Same thing at about 3.5, 4 years, we see that there's coordination costs, but after that, boom, we see an upswing. Now, importantly, though, what this tells the funding agencies is stop funding these research centers for only 5 years. You're not getting a full return on your investment when you only fund. R01 grants, fine, keep funding at 5 years. Research center grants, think more along the lines of a 7-year. By the way, the NIH has actually been working with a cross-agency group, 23 federal funding agencies, on making changes to their policies because of the data that was presented here. Oh, this just looks again at the number of publications and variation, and again, just showing some more data that says the research centers outperform, at least in areas of publication and citation as well. This looks at the citations that have been adjusted over time, and we see that the research centers, not just publications, but the citations of their paper, higher impact of the research that they're producing. Very, very compelling, and one of the most compelling studies where the funding agencies are concerned. I want to switch a little bit and start talking about the science and the practice put together. Communication is really very important, and as one of my collaborators who's from a school of communication said, communication is elevated to the essence of collaboration, and I think she's right. But communication is really the issue because it also involves trust, and we build trust with one another, not because we know each other or we sit in the same room or even affiliated with the same institution, but because we're communicating with each other. We know that there's societal, organization, and group and individual factors that enhance or undermine the trust that we can build within the research and collaborative teams. Good news is scientists not likely to have the groupthink problem. We tend not to agree, ever. You get a bunch of us with different opinions, and we keep our different opinions. But that does mean that we have problems with misunderstandings and conflict and disagreements. We also have this bad problem of a lack of recognition of one another's expertise. Clinical to basic sciences, med school to main campuses, physical scientists to social scientists, anybody who's not like us, we tend to be very biased about it with some very significant implicit biases. Cultural differences, paradigm assumptions, understanding what constitutes proof in our science. So it's really critical that we have to focus on issues of communication to build trust, because trust is not naturally there in cross-disciplinary collaboration. We know from the literature that face-to-face interaction when building the team is really essential. So despite our attempts at having things like email and web servers and webinars and sharing sites, every once in a while we just have to get together. We're human beings and we like hanging out with one another. So we have some issues with lean communications, such as email and video conferencing, right? How many of you have ever been part of an email string where a whole bunch of people have misunderstood what was originally said or the tone? Right? So we have to, it does strip away this personal interaction that we need to build trust to enhance communication. So at least at the beginning, teams have to be able to get together to build trust, and then periodically to be able to recharge the trust that we have. Now, this is good, and you can put this, this reference into all of the grants that you ever write where you're asking the agency for money to bring people together in one geographic location so that they can all meet in person. So back it up with data, and you've got a better chance of getting it funded. So there you go. There's your reference on that. It's also important to think about communication and trust. At the time you're establishing collaborations, we tend to do that pretty well, formalizing the collaboration. But during the process of when we're collaborating, we forget that communication and trust continue to be necessary components, and we have to shepherd both of those. We have to manage conflict then too. A lot of times people are very enthusiastic at the beginning of a project and there's not a lot of conflict, but as things get underway and their differences get in the way of us, so does conflict. And something we don't like to talk about, but how's the collaboration going to end? We don't like to talk about things. Unlike a marriage where we hope that it wouldn't, collaborations tend to have a start and an end. But we don't like to talk about the end. It's very hard, and it's into the future, and if it's past 5 years when we're used to writing grants, it's even more difficult. But these are some of the places where we need to think about it so that at the end of a 5 or a 7 or a 10-year collaboration, people don't leave with very bad hurt feelings. So some of the things. Now, the good news is that the NIH, they're my favorite in this, spent a lot of time and scoping out the literature and understanding about conflict, and they developed a really terrific free online resource that you can get called Collaboration in Team Science, a field guide. And in it, there's case studies, so it's great for classroom material, but it's really, really good, especially for early career researchers and those who are just starting to serve in leadership positions for collaboration, where the field guide has information about developing goals and vision, dealing with conflict of interest, how do you manage issues around authorship and credit, and all kinds of other things. Really, really great, and everything in there is evidence-based. And as I said, you can get it for free. So you can download this. It's a PDF. I suggest any of the faculty. This is a great thing to share with all of the members of your team, postdocs and graduate students. And grad students and postdocs, I highly recommend you download this. It's a great resource. Other things that have been developed, right, this is our cross-disciplinary thinking, those philosophers. Yes, those philosophers actually do research too, so they can be considered science. Funded by a grant from the National Science Foundation, this group of philosophers from Idaho, right, of all places, Idaho, it's very pretty, but it gets cold there too, just like here at home in Chicago for me. They developed something called the Toolbox Project, and it's a collaborative communication workshop that has philosophical underpinnings around enhancing collaborative team science. And the way this works is that you get members of your group, or a classroom, your team, or it can be members of a classroom, and you really get to come together to talk about motivations for engaging in science. And so here you go, there's issues around epistemology, right? That's a great philosophical term. I had to work at saying that. That wasn't something, I took one philosophy course as an undergraduate. But this looks at, for instance, issues of motivation, where the core question about the principal value of research. Does it stem from its applicability for solving problems, or its potential for making basic discoveries? And then everybody, it's part of this workshop, you answer these probing questions, and there's about 35 of them altogether, and you answer relative to your perspective. So if it was me, I'd say applied research is more important to me than basic research, and I'd be right in the middle, because I think they're both important. And I'd say collaborative research is better suited to addressing applied questions than basic questions, and I would say 5 agree. But now maybe I'm working with, I don't know, an organic chemist, and they have a different perspective. They're really into the basic research. Or maybe I'm working with my younger self when I studied electron transport chain in E. coli. That is like as basic as you can get. You know, I really thought basic discoveries and knowledge for knowledge's sake was the best and the end-all be-all. And I would have answered these. Now, there's no right or wrong answers. But after you answer your own questions, then you engage in dialogue with everybody else in your team. And you find out that people have different perspectives than you do. And it offers the opportunity to understand how people are thinking, how they're motivated to engage in science, and where you have the possibility of real conflict as your collaboration goes on. But even knowing in advance where you may have issues of conflict or where you have issues where you can come together can be very helpful and allow you to manage those problems going forward. What's great is to have more information. You can host these folks. They'll come and do a managed workshop for you, or you can just get the materials online and you can conduct your own workshop. You can also have people trained in conducting these workshops here at Tulane, and then they can offer them elsewhere. For those distributed collaborations that I told you can be very highly successful but can also fail often, the folks at the University of California, Irvine have developed something called the Collaboration Success Wizard. This is based in a large part on about 25 years of work under what's called the theory of remote collaboration. Very well published, and one of my favorite articles is one called Distance Matters. It's an online diagnostic tool for geographically distributed collaborations. But what I really love about this is that it looks at both the social and the technical aspects of individuals and of the collective team. So it looks at the individual micro level as well as the meso level. The only downside is that it takes about 35 minutes from start to finish, and I do find that busy research professionals don't always have 35 minutes to spare, and it's best if done all at the same time. But it provides great fodder when you're going to go forward and apply for a major research center grant at the NIH or the NSF, because you can have preliminary data, not about your research, but about the team. You can understand where you have great strengths collectively and where you have particular needs. And so if you find out that you don't have good technology to support the collaboration, now you've got some data to back up in your budget the request to have some video conferencing technology that's being built. So really, really great. I strongly encourage using this tool, which is free and online, to anybody who's thinking about preparing a new large research center. even if it's not for the purposes of applying for external funding, but it does help you in positioning things, whether you're looking for internal funding or if you're looking for external funding not from the federal agencies. One of the other big aspects around team science and things that we concern ourselves with is in the area of leadership. And thinking about crossing disciplinary boundaries, and it can't be everybody on the team doing all the crossing, but it does have to be spearheaded by the leaders. So we're going to look now at some of the literature that we know around leadership and team science. There is great value in multiple leaders for projects, so I don't want you to think it's a bad thing, but it has its place. So having multiple leaders where there's not one person at the apex is really quite valuable for larger, more dispersed teams, especially those that are engaged in community-based research, that you might have external sites and a need for the community perspective, but they're truly physically, geographically located separately. It helps that ensuring separate units build buy-in and commitment to the overarching team goal, even if you have different perspectives around that goal. However, though, if you have multiple leaders, you have to design effective coordination, and you have to make sure that there's good communication and sharing of information. And you have to increase the sustainability of collaborations when the results need to be disseminated to community participants especially. And one of the things we're constantly challenged, I was working with a neat collaboration of folks, and everything was going great until the day I received an invitation to come and speak. Well, it's great, and I can accept on behalf of the whole team. Now, it would be pretty hard to have a talk where 17 people are all talking parts, right? That would just drive the audience crazy. You'd never get anything in. So we really had to decide how were we going to manage issues around invitations to speak. It all worked out in the end, but you know, you have to think, how are you going to disseminate? Only one person can talk at the same time. Only one person can be listed as the first author. It's a challenge, but they're challenges that we need to deal with because that's how our academic structures work. Something we think about all the time, this is the movie Moneyball from a few years ago. So it's got Brad Pitt and Philip Seymour Hoffman, which he was outstanding in and unfortunately passed away this year, and Jonah Hill, who is a riot. If you have not yet seen this movie, whether you're a baseball fan or not, it's about baseball, but it's not. It's about science. It is the perfect analogy for all things science. Plus, it's fun to watch Brad Pitt for 90 minutes, so that's cool too. But what it really showed, and they had a new model for doing baseball teams, is that the team of experts does not necessarily make for an expert team. But unfortunately, that's sort of our MO in academia. We collect all of the very best of the best in whatever field, and then we try to put them together, and we expect great things will happen. But it turns out that we need not just the right mix of expertise, we also need team players. And a little bit of coaching doesn't help either. Because we have to be able to use that collective, complementary, and sometimes at odds and differential expertise. I was thinking about this. We just came out of an Olympic season again. And what I noticed is that whether it was a team sport or individual, there isn't a single Olympian or set of Olympic teams that didn't have a coach. Can you imagine an Olympian going to the Olympics without a coach? And of course, you probably know, like if you think about it for a minute, most of the time, the coaches do not have the athletic capacity that the athletes that they're coaching. The athlete's abilities supersede that of their coach, but having a coach is still really valuable. We saw that, right? Here's the mix of just experts. This was the original Olympic dream team, the basketball. So they took the very best players in their position from the teams around the country and put them together. And well, let's just say they underperformed, okay? By comparison, on the other hand, though, I'm a huge hockey fan from Chicago. We won 2 Stanley Cups, you might have heard. Yeah, so I'm really a big fan. Rock, it was so awesome. Okay, so we're in the middle of playoffs now and everything, too. This is the 1980 Olympic gold medal winning team. But do you know, they're not really famous for winning the gold medal that year. Do you know what they're famous for in 1980? Whopping the USSR, right? The Soviet Union just squashed them. And these guys were serious underdogs. They did not bring the best players in the best position. They brought really solid players from all over the country together and an amazing coach. In fact, a coach who, by the way, had been recruited to an Olympic team, but a week before was cut from the team. He never played in the Olympics. But he had a whole team of guys who did, and he made it to the Olympics. And they spent months and months of working together to play as a team, not worried about the individual expertise. Some studies, in case you don't believe me, just from sports analogy, there's some real studies that were done at Harvard University by researcher Dr. Richard Hackman, who unfortunately passed away last year, looked at expertise in coaching in some task-oriented studies. These are the nature of science team are task-oriented. It turns out if you have a group that doesn't have a lot of expertise and nobody to coach them, you get poor performance in the activities. It turns out that if you have people with a lot of expertise and a really good coach, you get some of the best performance, and that makes some good sense. Here's my favorite, though. If you don't have a lot of expertise, but you have a really good coach, you can get pretty decent performance. The worst case scenario was when you had lots of experts, but nobody to coach them. That's really how we try to do things in academia all the time. We have the problem of too many cooks in the kitchen. So these are also lessons for us on how do we enable teams at our own institutions. We bring in coaches, and they can come by a variety of names. They can be professional staff. They can be folks with MBAs. They can be scientists with PhDs who just aren't interested in pursuing their own research, but working on and facilitating collaborative research. And that was the role that I had at Northwestern. So significantly impaired performance without a coach. Lots of experts, but no coach. Something else we know for leaders in terms of assembling and putting together the teams, this is really important. Some great science that was done by my former collaborators at Northwestern University who are in the Kellogg School of Management, so out of the management. They looked at different teams, and they did a retrospective study by looking at teams across lots of different disciplinary domains, including Broadway musicals. Yes, Broadway musicals. Now I know that is not a scientific discipline, but it is a passion of one of the key researchers, and he, just for fun, wanted to see if people in teams behaved the same way, regardless of what the nature of the team was. And it turns out it's so. So Broadway teams and science teams behave the same way. But in terms of scientific teams, having a higher fraction of incumbents versus newcomers, incumbents being people who are experts in the field, have a lot of knowledge base, that's better because they contribute a lot of expertise and know-how to the team, but only up to a point. If you have nothing but people who are experts in the field, they were supreme, and you don't bring in new ideas, then you start to see a reduction in the impact of the science. They also demonstrated that more diversity is better, and that teams that are less diverse typically have lower levels of performance. They also showed that you shouldn't constantly repeat collaborations with the same team members. Because again, not the problem that you have groupthink, you just stop bringing in the new ideas that add towards innovation that collaboration is so good at. We also know from this that teams formed by members who have large but disparate networks of collaborators and of outreach folks, they can draw on larger groups of knowledge, and those teams perform better. So one of the things that you can do then based on that data is you can visualize your own LinkedIn network and of everybody else on your team. This is my LinkedIn network. It's visualized through a free